All right. Well, thanks everybody for joining. Thanks Viva for hosting. Just wanted to start out by congratulating you on your MVP award. It's pretty exciting. So, congrats.
Thank you. Thank you.
I know it was a couple months ago now, but I haven't talked to you. So
this group has been part of that journey for sure.
Yeah, that's awesome. Yeah, you've done a lot, so that well deserved for sure. All right, let me go ahead and share my screen. So I am going to just do one caveat here. For some reason, my PowerPoint and my computer have been not getting along. So a couple times it's locked up, but I have a really quick way to get back. So if I disconnect real briefly, that's what it is. So again,
I will let you know, Mike, but I can see your screen now. You're sharing your slide deck.
Perfect. Yeah, so hopefully we won't run any issues, but I actually did run into a real short issue at HTC, so not fun there. All right, so tonight we're going to talk about microservices and AKS, or Azure Kubernetes Service. So just real quick about me, I won't go through all this stuff, but this is just some of the kind of community involvement that I do. I'm a solution consultant and director of our delivery engineering. You notice I was introduced as Deliveron, but we've actually now, I think it was just a few weeks ago, we just relaunched, actually the week of HTC, we relaunched with a brand new brand and company name called Lunavi. So we're really bringing together what we did as Deliveron and the company that purchased us, Greenhouse Data. And so now we have a brand new name there. So that's the difference you might see at the slides here. So just a couple other things. I'd say by the base thing, feel free to reach out, contact me anytime. There's my Twitter account. I'll put my email also in the chat there. But yeah, always excited to talk to people about anything around Azure, Azure DevOps, DevOps in general. There, I am organizer of the Omaha DevOps meetup. So we're also on the meetup.org there. So we're looking for speakers if anybody's interested in speaking at that event. All right, enough said. So let's get into the topic. So the first thing I want to kind of talk about just here is, from a standpoint of, I'd say containers and Kubernetes, probably a little late to the party. And what I mean by that is really from a microservices standpoint, I'd say probably almost all of our applications that we're building and such right now, the back end, it composes of, I'd say either microservices or microservices type architecture. But we've really been focusing around building them on really the Azure PAAS platform or with Azure Functions. So really with that, we just haven't really done a whole lot around the actual, Kubernetes. And I'd kind of probably call a little bit of dragging feet. But, we've done that for a couple of reasons. I'd say a lot of the systems we're building, we're really helping organizations like replatform their systems with brand new tech stack of like .NET Core, Angular or React. We're also, helping them move to the cloud and incorporating DevOps practices. So, just to not make it too much, we really haven't got into a lot of systems building Kubernetes yet. The other thing too is there's really been kind of a limited enterprise features with AKS up until probably a good year ago. I'd say that's when it came close to, like, I would say the requirements that we've needed to really start building enterprise systems in I'd say in Kubernetes. And then the other thing too is I'd say a lot of what we do is more developer led. So again, from a organization standpoint, security teams have seemed like they've been much more open to building systems with PAAS, where we don't have like an actual VM. But when it actually comes to systems that use VMs, there's a lot more concern and stuff of how we do that in Azure. So, with Kubernetes, before AKS came around, really the only option was doing it in something with, building your whole infrastructure through virtual machines. So, kind of why did I start down this path? So like I mentioned, kind of late to the game, but I spent probably the last year really starting to look at what we're doing from a PAAS standpoint and serverless standpoint to really start addressing what we're doing and how we can actually build it. I was actually just going to drag this over real quick. This is a OneNote I put together of just a lot of the concerns and needs. We're basically you can see here, we've basically a lot of these things like versioning, service to service communication, different technologies, like kind of where things are at there and some of the gaps. I wasn't really trying to specify it into a actual, like the solution is going to be containers and AKS, but a lot of it where it's really kind of started going down that path and really there. So some of those concerns that I had listed in there was the first one with PAAS resources. They're public by default, and there's access restrictions that are kind of difficult to manage with that. A lot of times we had to do IP restrictions. Thankfully, now that they have service endpoints and private endpoints, that's made it easier. But there's definitely some challenge or private endpoints. It can be costly, like you have to use like the right tier of app services and so forth there. So still some kind of challenges with that. Service to service communication can be kind of brittle. I put in here ARM templates, which might be kind of interesting to people is why ARM templates would be here. But, we're building systems with like 20 different microservices, all with their own pipeline, their own infrastructure. Our ARM templates tend to be, unfortunately, more of a snowflake than, kind of a standard. So those become more difficult to manage. So that's one of the challenges that we often see with that. And then when it comes to like our debugging and local development, I don't know if you've ever tried to start 15 Azure functions on your machine, but it could be definitely challenging to do that. Or if you have one function that you're trying to debug, but then you're trying to point back to all of your other app services or Azure functions, that local development and debugging can be a challenge with that. So how does AKS and Kubernetes solve some of these problems? Well, there's definitely there's some advantages to this. The first one here is by default, or for the public access, you have a lot more granular control with it, Kubernetes and AKS. Like you can basically control whether you want services to be private only or public with just basically a service type configuration. So that makes it much more easy to manage there. From service to service communication, there's something I'm going to show you guys in a little bit called Dapper, and that provides some nice cross-cutting concerns from microservices standpoint, and it can really help with some of these, like adding mutual TLS between the service calls, and then just being able to manage them. Because sometimes when you're trying to make those like direct calls, it can be kind of brittle because you have to like specify names, those change in different environments, and could even change if there's like failovers to other regions and so forth there. From an ARM template standpoint, really our main infrastructure just becomes AKS. So whether we use an ARM template or use like the AZ command to do that, we can, that's the single resource that we're configured with that. Everything else is really configured through some YAML scripts and like Helm templates, so that it makes it really easy to build that out. And then the last thing to just kind of call out is there's from a debugging and local development, there's a couple tools that actually help make that pretty easily. One used to be called Azure DevSpaces, and it's still there. It's going to just deprecated now, but it's being replaced by a tool called Bridge to Kubernetes. And the Bridge to Kubernetes tool in both Azure DevSpaces kind of works in a way where you can deploy just your changes and deploy it as like a different subdomain, and then it essentially works. And you can test out those individual changes along with all the other normal application stuff there. So that's really nice. The other thing, there's a project called TYE, and that's basically where you can actually configure all your services to run locally, and it works really nice for managing that. That's like an early kind of research type thing. But if you go back to, I think it's the Build conference, there's one called Cloud Native with AKS, and they like half the talks on this TIE tool, which is pretty cool. And so they're still they're still actively making changes to that. So hopefully that'll turn into like a real product. But right now it's just kind of more of a research type thing. All right, so we talk about Kubernetes and AKS solving all these problems, but it's also doesn't fix everything in the world, right? Yeah, what types of things does it not fix? Well, first one's complexity. We already talked a little bit about that with just a whole nother thing to learn. But there's a number of tools here, and I only included probably just a couple here, but it's like a whole real ecosystem. But Docker, Kubernetes, Helm, the AZ command, a lot of them, and these are all CLI tools. So there's a lot of commands to remember, and even just coming back into, in my role, I don't do like the active development every single day. So I'm coming in and out of stuff, and I have to kind of go back and remember what some of these commands are and stuff there. So there's definitely that kind of complexity. The other thing is, with the PAAS, you're really not worrying about the underlying OS. With containers, it's kind of it's a part of the OS, but there still is kind of an image management. You don't patch it, but you basically update like your base images with the latest patched version of that image there. And there's types of things that would, you have to make sure like different software and things like that aren't on there. The other thing, security, kind of goes along with that image management. Like you have to be able to know what's on those. Now you have to actually, do some sort of virus scanner, do some sort of checking. With one, I was talking with somebody, and there's a concern that their Git was on some of these images, and these were being used in prod, and that was one of the kind of security rules. You can't have dev tools on prod machines, including images there. So a lot of things around those types of concerns with that. The other thing too to kind of call out is, once it's not just kind of a fire and forget, there's that operations and management piece is definitely important to know. I mean, this part of Kubernetes and AKS, it's really about the whole entire life cycle of your application and be able to manage it. So there's a lot of pieces even after it's in production. All right, so now let's jump into really more what that is. So, and I don't know, it's kind of hard without being able to do. I guess you do have the hand raising in Teams, but it's hard to get kind of a pulse from the group here of, what is, where, what everybody's at. But I'm just going to start out here just talking real quick about Kubernetes and AKS and kind of going in through what that is. So really what it is, it's an open source orchestration tool, for deploying and managing and scaling your container applications. They're really built by Google to really for their workloads. I think it was called like the Borg or something like that, if I remember right, before they actually kind of productized it, and becomes this tool. And there was really a number of them. If you kind of were looking at it back in the day, there was like Docker Swarm and DCOS and Mesosphere and a couple other products that Service Fabric from Microsoft, and Kubernetes has really become the primary option. There's still probably Service Fabric for a lot of Microsoft people, but in general, Kubernetes is the hands down winner of that kind of war. And I think that's kind of gone. Even Docker themselves, if you install Docker for desktop, you can install Kubernetes with that to get that running there. So that's really kind of what that is. From a AKS perspective, it's really now about having a managed kind of running instance of the Kubernetes service. And what's really nice about it is you don't have to worry about the underlying servers. They're still there. And depending on how you set it up, it could be a VM like ScaleSet, but again, it's managed by AKS, and you really don't have to do anything from a VM perspective. And the other thing too is they've made it to where you're really just paying for the servers that you're using, or the compute power, I should say. You don't have to pay for the compute power for this, like for the management piece. And we'll talk about the management piece here in just one second. And so that kind of gets into the infrastructure side of things. And that's the control plane. So the control plane is there on the left, and it's really about the kind of the management piece of of the actual tool itself, and that's where how you would access it through either like kube control or through the portal, or maybe not necessarily through the portal, but through kube control for sure, or through some of the different APIs. What's managing there, and then what you actually pay for, or what you're actually using, is what you're deploying to it and the resources that consumes. And so that's over there on the customer managed side of it. They're also working on ways to make that more of SLA. So there's SLAs on the on the customer managed side, but they're also working on basically ways that you can have it so the control plane is actually has an SLA on there, because that was one of the concerns kind of from an enterprise standpoint. And one of the nice things though is, even if like your control plane goes down, that doesn't affect your running applications. But if you wanted to deploy it or make a change, you'd obviously want to be able to get to that control plane. So still definitely a concern with that ever going down. So the next thing here is about, from an infrastructure standpoint, is your nodes. So think of the nodes as really your VM that's running them. And it's a kind of a fixed amount of compute that your application will you'll kind of carve off, if you will, to be able to use those and run those workloads. And you can see here, we also have what's called like node pools, where you can group nodes together with the same configuration. So that's kind of the infrastructure side. Now more the workload resources. This is where you probably primarily kind of work out of there. The first one, and probably the primary one, if you've heard of the pods concept, it's basically that unit of work in Kubernetes. So it's just a single representation of work. Now what's interesting though is it can be more than one or more containers can live in a single pod, which I think actually turned out to be a really smart design. We'll talk a little bit about sidecars here, containers. So get a little Vice President flying around in here. The pods, the thing about those is they share the same network, same process, same memory space. So they're really, from a pod perspective, like all one machine. So it's pretty cool how you can basically share that. You can basically have the machines or the containers talk to each other through localhost and be able to do some stuff there. So you don't create those pods directly either. You basically do it through what's called a controller to say, go create this and manage that. There's another kind of resource called deployments. So this really describes the state of the resources and kind of manages that. They're represented in YAML files. Here's an example of that here. This represents kind of what's actually being built. You have the resources that it is containing, and what container you're actually using in the actual with the actual application there. And you see the image name from like your container registry, if you will. The next one's called service. So service is really there to provide the networking and essentially how you're going to use your deployment, or what you're deployed, and how it's going to be accessible. So whether it's different node-to-node communication or to your users there. As you can see here, this rating API it basically exposes port 80, but on the back end it's going back to port 3000. One thing here, this type called cluster IP. We'll talk about that here in just a minute, but just kind of keep a note of what that is there. The next one's called replica set. That's the other kind of resource. And what this does is this manages the instances of your pods, and basically it manages the whole life cycle of them. You can see, remember, pods and containers are going to be more like cattle instead of pets. So if that one goes away, it'll basically bring them another one to replace it, and that can happen for numbers of reasons, deployments, so forth there. But really the idea is we've got three. We specify that we want 3 replicas, and you can see we've got essentially that. The next thing is namespaces. So namespaces are really just a logical boundary for your basically your resources in Kubernetes or AKS. So you can basically group up your resources. And it's really nice too, because then you can basically use AKS across different products, even different environments, you can group it by different types. So you can basically do all those different types there, and you can group them together. So it makes it pretty nice there. So those are the workload resources. The next thing we want to do is talk about service types. And this is really important from how we want the different services to talk to each other. The first one is cluster IP. So if you remember from that configuration file, that service configuration that we just looked at, the configuration there was using cluster IP. And really what that means is we're just going to do internal communication. So like our back end communication or kind of our container to container, we'll want to use actual cluster IP there to talk to the different pods. The next one is node port. So this is one I really don't like. I haven't actually configured this one here, but this is really more just the next one that we'll show is kind of a flavor of it. But this basically creates a port mapping so it can be directly accessible, basically with the node IP and port. The load balancer, this one you've used a lot more. Basically, this creates the ability to do that load balanced resource. We have that single entry point, and then it can scale it across the different nodes to the different pod configurations. And then with this one, this is where you can configure like your external access. You can also do like an ingress controller, which would serve like a load balancer there too. External name, this is really just providing that like specific DNS entry for your application access there. So that's kind of the service types. From a networking standpoint, there's really two options. There's KubeNet, which is really the default basic option. It's where essentially Azure can manage all your VNet resources. I'd say use that for smaller kind of maybe test workloads. In this one, the nodes and pods actually get IPs from different subnets, and then it has to do like NATing to the node's primary IP address. So it's more like if you don't want to worry about the VNet settings, it can kind of basically take care of it all for you. The other one though, Azure CNI, that's more the advanced, and this is even some of the features in AKS require Azure CNI. So this is what I'm used for like production workloads there. In this case, every pod gets an IP address. And so that means it's actually directly accessible. And then the traffic to the endpoints is really in the same VNet. So there's no natting or anything like that. So I think it's cleaner myself. So that's really it from just kind of some basics about Kubernetes and AKS. There. So the next thing I want to talk a little bit about is microservices, right? Because that's what we're kind of talking about for this. So microservices, obviously, it's really become a term that's very widely used. But some of the things that we're really trying to solve with this is basically taking, I guess probably previously known as monoliths, and break those into smaller parts so that we can actually deploy those independently and be able to release those without releasing the whole entire thing. So the idea is we can break things down into smaller batch sizes so the changes are smaller and we'll have less risky changes to go on there. So that's what we're really trying to solve with these. There's definitely challenges though with this. Run into quite a few people where they're like, oh, we want to do microservices. And they're like, well, if you do that, do you know what else comes along with that? And again, it's not just like architecture. I know a lot of times it's like microservices architecture, but really to get the full benefit of it, there's quite a bit of other changes that have to be like, you really have to have the right DevOps practices to be able to deploy. You have to be able to have those pipelines to go, or else you're really not taking advantage of it. You have to be able to kind of separate your data out. One of the challenges that I've seen is people start breaking up their application, but they don't break up the dependencies. And so instead of creating microservices, what they really created was distributed monoliths. And so really get the worst of both worlds. you still have to deploy all your microservices together, but they're now separate deployments, so it becomes a nightmare to try to manage those. So really make sure when you are breaking out those microservices, you're doing them in a way that those can be deployed independently. Because if there are dependencies, and if it's a good kind of litmus test, if you're having to kind of coordinate your deployments between them, then that might not be a good boundary for your microservices. The other thing is probably more than a technical problem. There's the engineering practices, like I mentioned, but also the people and culture. So there's a lot of times organizations where there's a lot of red tape to get things into production. And, a lot of different groups a lot of manual approvals. A lot of those things have to be kind of unwound to be able to really get the benefits of microservices and be able to deploy to production with less friction there. And value stream mapping is a really good technique to really help start identifying that. But yeah, you just need to make sure when you are saying you're going down microservices, and it's definitely much more than just how you're writing your code. There's other things associated with it. I haven't looked if there's any questions. Any questions at all out there yet?
No, I don't see anything in the chat window yet. I think either it's too much for people or they already know this.
Yeah, it could be. So,
yeah, I would like to just remind people, if there are any questions or comments, feel free to post it on the chat window.
So, so we'll talk here then about some of the benefits of using microservices in AKS. So obviously, we talked about microservices in general, but some of the benefits here. First thing is it's now containerized. And I'd say that's probably, I think, one of the key benefits is you can actually do development on your machine the same way that the application is going to run in production. That to me has been one of probably the best benefits. Is there always, regardless of the tooling, it's, we can always get different results running on our machine versus running it in production. But if we're using the same exact image, essentially creating the container and running it locally the same way, this containerization is really a key benefit there. And even some of the tools, if you're using .NET and using Visual Studio or VS Code, they've got some really nice tooling how you can basically like mount a drive on the container and even step through and debug your code directly on there, which is pretty cool. Easy deployments that we can do independently. Again, doing that all through AKS makes that really easy. Easy to control those access restrictions. Like we talked about, we can actually control, we can do RBAC controls for who can have access to it. And then also from a deployment standpoint, it makes it really easy because we already have the AKS infrastructure in place there. Real easy to create, public facing APIs, to do backend APIs, and even do like cross API communication with that. So there's some of the benefits here. So one of the other things too is that, with some different platforms is we have to basically kind of reinvent the wheel, if you will, every time. But with AKS, it's become this whole ecosystem, and there's been a lot of kind of tooling put on top of the services and of the orchestration tools. And there's some really nice ones for cross-cutting concerns. The first one is Service Mesh. So there's several tools out there, Istio, Linkerd, and a couple other ones that basically provide a lot of capability for being able to do like TLS communication. They actually have some of the testing capabilities built in there. So like Istio, for example, you can do even some like Chaos Monkey type testing and do that, but it handles that. That's one thing I haven't got too much into with this is the service mesh piece of it, but that's definitely I think there's a lot of interest in those types of things. Think about a lot of the like cross-cutting from a networking standpoint. can be done through that service mesh. So if you're that term, like tools like Itio are the ones for that. The other one, API gateway. So when we're building microservices, that's a very common pattern for how we want to expose those services to our clients. And so we can do that in a number of ways. We can use ingress controllers from like Nginx. We can actually use like App Gateway in Azure. We can use API management to provide that API gateway. So there's a lot of options for being able to do that. And in that case, that's stuff we don't have to do inside of our actual APIs themselves. This other one is called Dapper. Dapper is a tool that Microsoft has created, I'd say probably late last year. They created it, and it's a pretty cool tool. It really helps do some of these cross-cutting standpoints. Not as much. There's a little bit of overlap in what the service mesh does, but for the most part, the service mesh is, again, more like on the infrastructure or networking side, whereas the Dapper cross-cutting concerns is more on the development side. So let me show you here real quick. Here's just a kind of a high-level overview of what that provides. And it helps. I'm going to show an example of this just to kind of show what it can do. But it really helps from a service-to-service invocation. It abstracts that from the actual implementation. So you don't actually say, oh, go call the customer API URL, which is, HTTPS, blah, blah, blah. It actually can look that up and knows what to call from that standpoint. It kind of abstracts out the state management piece. So like you can swap in and out different state managements if you can use Redis or, table storage. That, your APIs don't really need to worry about it. Dapper, you can basically configure Dapper, and Dapper will handle that state management. Also handles things like pub and sub. So you can set up, subscriptions and topics there for actually publishing messages out. Again, something that is pretty cool when you consider that you can do it across all these different platforms and languages. Like some of those don't even provide that kind of capability there. There's also resource binding and triggers you can set up. It does provide kind of an actor model. So for like, your virtual actors with like, kind of like Service Fabric without, with just the good stuff, let's say. And so you can do that actor model within here, and it, again, just kind of abstracts it all. So you don't have to worry about that. It can handle things like distributed tracing, which is really nice. Some of the service meshes do handle the kind of distributed tracing too, but when you do it from here, you're kind of doing it from within the context of your actual like services. So maybe your service calls a service bus or something like that. That's different than just an API to API call. This can actually do a better job tracing that there, and then you can extend it and build your own there. So the real key though is it works across any. And the demo I'm going to show here in just a minute is an example of. I wish I could claim that I did this one. This is just an example. This is one of the quick starts they have out there, but I think it does a really good job showing the different platforms that are being used. So with that, we're going to switch to a demo here. I was just going to see any quick questions. Any of them that here, we got a comment here. Microservice needs separate database for each microservice. Defining domains is the hardest part. That's a really good point. Event storming is a technique that you can use. I don't know, I didn't read down, maybe somebody probably made the same thing. But, event storming is a good way to help kind of right size those domains and service boundaries. It's basically a way you go through and identify the inputs and outputs of your services. And basically it's a way to kind of organically come up with them to kind of help do that. The next question was a way to kind of break those up. Kind of goes on that line. With that, I think the other piece with that is there's a pattern called strangler pattern. And with strangler pattern, it can be used to help kind of identify different pieces and break those out. And I think that's a really good way to start microservices. It's almost easier to start with breaking something up than trying to start from scratch. Sometimes it can be too, it's really hard to get the right level there. So yeah, good points and questions. All right, so let's jump to a demo here. All right, so the first thing you want to show is just the actual example itself. This is called the distributed calculator example. And in the distributed calculator example, it is just a calculator. But what's pretty cool about this is every operation you see over here is handled by a different microservice and actually a completely different language. And so it shows how they can all work together and make it really easy here. So it's just going to pull up the web console. And just to show how some of the messages here, so you just see 5 times 4, real easy here, but then you see kind of how it's persisting the state. Again, one of the things it's using Redis cache in the back is the state store, and it could be any number of providers of that. But what's pretty cool is I'll store it here. I could even close this, come back in, and it could continue on because it's basically stored in there. And none of my applications know anything about accessing it in Redis. So this is kind of the calculator here. I think you can probably get the idea. We don't really need to do any more calculations, but yeah, pretty cool how this works. So let's actually now switch over here to VS Code, and I'll show you what that looks like. Let's see if I can. I should have looked to view how to zoom in. Remember the zoom in keys here? Maybe I can only do it in the editor. Well, anyway, so this distributed calculator is one of the repos out there, or it's in the examples repo. This has a number of different parts to it. You'll see the React calculator under deploy. You'll see all of the different configurations. So again, we can just do the kube control apply and apply essentially all these different pieces to it. And each one of these are a different language. You can see I've got C#, that's the subtraction. There you go, Node, and then yeah, I think there's one other one there. But so if we come out here, so there's the .NET subtractor YAML file, and the way it kind of hooks these up is through these labels here with that. And you can see in this case, it's pulling in this image from that and then deploying it. So it basically deploy all of those. So if I come over and say, where'd that go? So if you come out to when you look at those resources, so in this case, this Dapper IO samples, I can come back to here and you can see if those are just basically images out in Docker Hub. And you can see there's the different, these are all the different images here that I'm using in that example. So again, there's the different pieces. There's the Redis cache that I mentioned. So it's basically just hooking up the state for this. The Redis was, I basically just deployed that through a Helm chart. And then if we come in here to the React calculator and the server.js, you can see here, I don't actually have instances. I'm just calling these essentially aliases, and Dapper itself knows how to hook that up. In addition, like the state store up here, I'm not calling into anything from the state store, I'm just calling localhost, and it's going to know how to invoke that, all that behind the scenes. So it's pretty cool how it can actually do that. So if we, I think there was, yeah, so the React calculator, it's another one here. So you can see these annotations on the actual, each of these that kind of tell Dapper how to essentially operate. So these different annotations and what images that it's using. So let me switch to the portal. And then if we come over here to our Cloud Shell, so if you guys, actually, let me just close this out. And then if you haven't used this before, inside the portal, there's the Cloud Shell. You can do either PowerShell or Bash. And it's really nice because then you don't have to install a lot. The only downside is you can't do anything sudo from a Bash command. You can just only use regular permissions. So when I was actually installing Dapper, that was, you have to do that locally and then push it out, basically up to it. So then you can connect. And then we can do something like our kube control and then get our services. And here you can see all our different calculator services running, the Redis caches. You can see here is that IP address, our external IP, that then is how we can access it. Let's see. So yep, so that's an example. Any questions at all on this? Actually, let me switch over. I can't see.
This is cool. Will you be able to share this code or GitHub or somewhere?
Yeah, actually, here, let me show you this. I will, dapper.io. So you just go to dapper.io.
Oh, it's a quick start template, you said, right?
Yeah, so you can go to dapper.io. This has kind of the quick starts on how to get started. This will take you to the GitHub repo. Mm-hmm. And then under the GitHub repo is, where did it go? What's the docs, I guess? Let me just go down. I don't know. So let's go to Dapper. I don't know why.
There are quick starts back there.
Yeah. Yeah, I must just click the wrong link here. So you come down here, there's the quick starts repository. And in the quick start repository, these are the different examples. The one I just showed was the distributed calculator. There's also one to show like PubSub and some bindings and such there. So really cool service. Again, they're on like version 0.11. So not sure exactly when this will become more of an official supported product, but it, again, handles some really nice capabilities. There's a bunch of good presentations from Build. I can't remember if Ignite had some, but definitely if you go back to Build, there's some good Dapper presentations in there. And hopefully there'll be some more announcements here to kind of get it into more of a formal product with it there. So, all right. Any other questions on that before jumping back to some slides?
I don't see anything else on the chat, Mike.
Okay, so, all right, so here again just showed all those cost-cutting examples. The other thing I want to talk about was scaling. And so in AKS, there's kind of there's different ways to do scaling. The first one is manually. Manually, you can do scaling just by your configuration. We saw a little bit about the resources and such. You can specify in the deployment, like the replica, how many replicas you want to have. So you can do that manually, but that requires obviously redeploy. Not as good there. But you can also specify, you can set up the horizontal pod autoscaler. And what that'll do is, like, your node has kind of a fixed resources, right? You see has a CPU, has memory, but you can actually configure the pods to scale up until you've essentially consumed all of those. And so that's one way of doing it. You can also do the cluster autoscaler. The cluster autoscaler will allow you to scale multiple nodes. So you can basically, once you consume all of your resources in your nodes, you can scale up to have additional ones. There's a couple other options here, which I think are pretty interesting. One is what's called a virtual kubelet. And what that does is that leverages, Azure container instances. And Azure container instances can basically dynamically create some more horsepower for you to scale out for like, a short burst, and then essentially those would go away. So that's a pretty interesting way. The last one I think is really interesting. If you think about all the ones I just shared, they're all kind of reactive. They're all like, okay, well, now that my AKS is starting to get slower or get to the maximum number of resources that it can consume, now I'm going to go ahead and scale it out to a lot more. So it's kind of reactionary, if you will. There's also a way to proactively scale those resources, and that's called, that's actually a tool that Microsoft helped come up with, and that's called KEDA. And what that does is that essentially does event-driven scaling in AKS. So it's pretty cool because, and what that is it's actually determined to be proactive when it comes to scaling versus reactive, because it can go by, like, let's say a service bus and look to see how many messages are out there. And if it starts to get more messages than it can consume, it can basically start scaling those out. So it works more like how Azure Functions does in consumption mode, to where it can dynamically build up more work. So it doesn't wait till it's consumed them all. It's saying, hey, I'm going to need more to actually complete all these. So it's a proactive way to do that scaling. So a lot of ways there. The next thing we want to talk a little about is pipelines and how we can deploy those microservices through AKS. So in this case, we can do all the building and packaging, handle our deployments, and then also building some of those kind of DevSecOps, if you will, capabilities inside of our tools there. So things like when you talk about like building and packaging, that's really the building it, putting it into a container registry, the deployments, pulling it out of the container registry, and dynamically spinning up the instances of the pods. And then with the secure DevOps, we can use some tools there. So let's talk a little bit more detail about those. All right, so this is an example of a pipeline utilizing really kind of more GitHub in this case, but it could be Azure DevOps or whatever your tool set is here. But essentially, packaging up our application, essentially doing our CI/CD process, or more CI, to then package it up into that Azure container registry, which again works kind of like that Docker hub, where that's where we can publish. With Azure Container Registry, that's kind of your own private registry, so you can push your images there. In there, we can scan the images and make sure everything is appropriate in those images. And then when we get to the release or the deployment side of our pipeline, we can then deploy out those pipelines wherever it might be, and then we can basically consume the different data resources that we might have. We can expose the applications, through those public endpoints, and then also you can have like an admin access if that's what's desired there. So that's pretty standard in the kind of CI/CD pipeline perspective there. When we start talking about secure DevOps, that's where we can start talking about some additional tools. There's the Azure Security Center, can do some things around different security, but there's also a tool called Aqua. I'm familiar with that, but they're really big on container security. And this is one we've actually set up, which is kind of cool. But it'll basically now go through and scan those services. There's actually kind of two different things. There's kind of an endpoint protection, but then it can also scan our images to make sure our images don't have any. You can see here in this case, this image here does have some vulnerabilities. So Aqua is a pretty exciting tool there. So we're just about coming up to the top of the hour here, and actually getting pretty much here to the end of kind of what I wanted to show. Any questions that have come up on the thing?
I don't see anything, Mike.
It's like Mr. Michael Nichols is typing something there. So we'll keep an eye on his comment here or question. So that's kind of that. So the last part I just wanted to share here was some links to, really getting started with this. There's some good hands-on labs. There's a couple of them here. There's this AKS workshop one, which is a great way to really get some hands-on experience deploying some services to AKS. There's one. This one's not updated as much, but this one's pretty cool because this one does go through some of the like Aqua stuff that I showed. You can actually set up some of the security pieces in there. So this is a good workshop for going through that. If you want to do some hands-on with some pipelines, the Azure Pipelines hands-on labs here is pretty good too. And then I've got a link to the DAPR resource there. So with that, that's kind of what I put together for tonight. So really, that was a good kind of introduction. Yeah.
Will you be able to share this slide deck so that I can share it? Okay. Yeah, that will be helpful. People can reach out to those links. So Michael says if you can show those links once.
Absolutely, there, yeah. And I'll definitely put it out there.
Lots of Michaels today.
Yeah.
Hey Mike, I had a quick question.
Sure.
On the AKS architecture where we have got two planes, right? The control plane and Microsoft managed plane. I mean, a customer managed nodes.
Yep.
So, I mean, I was thinking like if the control plane, I mean, Microsoft managed control plane, if it goes down, how can the agent nodes can communicate? Like if there are some updates, like how the synchronization can happen if the control plane goes down?
Yeah, so think of the control plane more as like, if you need to make a change,
right?
It's going to be those. So like if you're going to do any kind of cube control command, anything scheduled that you need to do, if any of the, I guess if a pod key went into an unhealthy state and had to be brought back up, like none of that could happen. But if, let's just say, it was like a momentary blip or something like that of your control plane, it would still allow you to work.
Okay. So like for every customer managed once we will have a new control plane, or one control plane will manage multiple clusters, multiple customer managed agent nodes.
So it's basically it's a one-to-one. So it depends on how you set up your cluster, but it's a one control plane to. The cluster is made up of your control plane and your customer managed piece.
Okay.
So if you have multiple clusters, you'd have multiple control planes.
Hey Mike, does it lets us decide to deploy the control plane in multiple availability zones on multiple regions?
I don't know where that product's or where that's at really, but I know they're working on that to again make that more of an SLA and give you more control over that. It's it's kind of the do you want the control or not want the control type thing, but there is some options out there. I believe it's either coming or it's out there in preview to
I believe you can do it with node pools. I believe that's supported by having your AKS node pools. Mike, you could put those in different regions.
Can you do that with the control plane though? I've never tried.
No. I'm talking about just the
yeah.
If you wanted to.
For the managed part, but yeah, I think I don't think you can do that with the control plane. But I think there's some option they're working on to make it so you can have it.
Or probably since it's managed by Microsoft, it might already be.
I think the whole control plane is managed by Microsoft subscriptions, so there won't be any visibility to the end customers.
And that being said, probably they might have already included replication for those components in control.
Yeah, I don't know where it's at, but they're in some process of I think, well, definitely in the past that control plane did not have an SLA, so yes. It could go down, and that was I think kind of a showstopper for some people wanting to use AKS. So in result, Microsoft's working on something to kind of meet those needs of those enterprise customers that need to have an SLA on that. I don't remember exactly where that's at though.
Thanks, Mike. That was a great presentation.
Thanks, appreciate it. Yeah, so that's pretty cool, Michael. If you're deploying that KEDA, that's pretty cool.
Yeah, and I'm just reading on Microsoft's side. It does look like it does support availability. Yeah, it says that you can use clusters with availability zones. So
that's good. So yeah, the availability zones would be essentially 2 buildings in the same
region.
Yeah, so it gives you some reliability there, but not all regions have availability zones, so be careful.
Yeah.
Where you're deploying it. Thankfully, Central US seems to have about everything. So.
That's a good call out, Mike. Yeah, South Central doesn't have, but looks like South Central is going to have availability zones in 2021.
Oh, nice. That's pretty cool there.
South Central is their most used region. They're always short of capacity in South Central.
Yeah, no, that would be nice. I know the one oops.
Hey, Mike, I don't know if I've been pronouncing that wrong, KEDA or KEDA, all this time, but basically it was just a really easy way for us to move to like serverless compute and then kind of use it as an event-driven model with the blob storage account. So it's got just a ton of different capabilities that I'm looking forward to take more advantage of over the year. So it's really exciting stuff.
Yeah, and I think one real good thing what you said there too is I think event-driven is, to me, the best way to do microservices, and really not have any direct dependencies when you're trying to do like server-to-service communication, like really keeping that to, using some sort of service bus or some sort of queue to kind of manage those messages back and forth from those services. Great. Anything else? I will just send you the slides and go from there. Well, thanks everybody. Appreciate it.
Thank you, Mike. It was a great presentation. The recording will be up by probably end of the tomorrow, and I will also publish the link to this description as well. On behalf of the user group, I would like to thank you once again, Mike, for taking time out and presenting today. It was a great presentation and very informative. Thanks once again.